Hey everybody, and today I just wanted to go over this little I guess discovery, conjecture, whatever you want to call it. I was looking at some math, saw this problem was x plus 1 times x plus 3 times x plus 5 times x plus 7 plus 15 equals 0. Obviously we're trying to find what values of x makes this 0, and of course we have 4 x's. This is a quartic. But what I thought was really interesting was something that'll come up later. You could call this my conjecture, my conjecture. Might come up with a proof for it later. I'll formalize it in a little bit, but first I just want to see show how I arrived to this conclusion, even if it is probably wrong or irrelevant or already proven. But whatever. So let's get started. First thing we're gonna do is subtract 15 from both sides. X plus 1, and then I want to I guess make some assertions, make some logical conclusions about the possible values of x. So we know that there is an even number of things we're multiplying, right? There's 4. These are 4 little terms, and they come out to a negative number. That means that either 1 or 3 of these can come out to be negative. Can I fit negative here? Maybe. Okay. So that means 1 or 3 of these can be negative, and obviously none of these can be 0. So automatically we can rule out some values. X cannot equal 1, sorry, negative 1, negative 3, negative 5, or negative 7. Because if any of these are 0, they're all multiplying, so they all become 0, and obviously 0 does not equal negative 15. So now, what did I do? Well, I did what every good mathematician would do, and I guessed and checked. I just plugged in some numbers. So what happened? Obviously, x can't be negative 1, so we're going to do negative 2. So what happens at x equals negative 2? Well, negative 2 plus 1 is negative 1 times 1 times 3 times 5. And we get lucky, this automatically comes out to be negative 15. Now, what do we do now? Well, that's 1, but it's quartic. So what are we gonna do? We're gonna plug in some more numbers. Yeah. So we already did negative 2. We can't do negative 3 because that'll get us 0. So why don't we try negative 4? Well, lucky me, I'm not going to write this one out because I already know the answer. Negative 4 plus 1 is negative 3 times negative 1 times 1 times 3. This does not come out to negative 15, so we're going to move on. Can't be negative 5, so we're going to try negative 6. This gets us negative 5 times negative 3. Ooh, disconnected 3. Give me a second. Times negative 3. Times, what are we at? Was it negative 1? Yeah. Negative 1 times 1. This also gets us negative 15. Now, as far as I know, these are the only 2 real numbers that we get. Negative 2 and x equals negative 6. Just for posterity, let's go, graph this out. X plus 1, x, ooh, that's 10. X plus 3, x plus 5, and x plus 7. So these are, okay, so you get what is this? Negative 5. Did I graph this wrong? Oh, forgot the minus 15. Plus 15. Okay, so negative 6, negative 6.449, negative 2, negative 1.551. Now, I have no clue how you would get those 2 other numbers. But we got 2 of the solutions from just guessing and checking. Obviously, it's a quartic. We have 4 actual solutions. How you would get them is beyond me. You'd probably use rational root theorem, something, or the quartic formula if you're mentally insane. But that is not the point of this video. Instead, we're gonna box this up right here, because I'm gonna try another one now. I'm gonna try another one, and I noticed the pattern when I tried the other ones, so we're gonna look at what that pattern is. And I'll erase this too. X cannot equal, we'll have some new numbers. Okay, so then, let's get started. Next one is, we're gonna do, if you notice with the last one we did all odd numbers, 1, 3, 5, 7, those were all odd, so we're gonna do all evens now. So we're gonna have x plus 2 times x plus, what is it, 4 times x plus 6 times x plus 8. And once again, I guess we'll have this equal to negative 15. Skipping the step of breaking 15 to the other side, because I don't want to have to rewrite the whole thing. Originally, I chose some arbitrary constant. I just chose like 24. I didn't get the solutions for 24, but the point is we're gonna have this equal negative 15 because we're gonna do the same thing. So now we still know that since it's negative and there's 4 terms, we need 1 or 3 of these terms to be negative, and now x cannot equal negative 2, negative 4, negative 6, or negative 8. So we're going to do the exact same thing. We're going to plug in the first term we can actually plug in. We're not going to plug in negative 1 because that's not going to make any of them negative. We're going to plug in negative 3. So we get negative 1 times 1 times 3 times 5, which equals negative 15. That's cool. Let me write this here. This is x equals negative 3. Now 4, we can't plug in. 5, well, let's just do this mentally. Negative 3 times 1 times 1 times 3. Not 15. Negative 6, can't plug in. Negative 7, we're going to have negative 5 times, what is it? Negative 1 times, wait, what am I plugging in? I'm stupid. Negative 7. That'd be negative 3. Negative 7 times, and then negative 1 times 1. This is equal to negative 15. Now this is at x equals negative 3. And so this is pretty cool. We're noticing the same pattern here. Negative 1, 1, 3, 5. Negative 5, negative 3, negative 1, 1. And then we get negative 15. I just wrote x equals negative 3. It should be negative 7. So now we have these two. And what we notice about our solutions here is they're just one off from each other. We have negative 2, negative 3, negative 7, negative 6. Now this makes, pretty decent amount of sense, or at least it's semi-continuous, continuity, so whatever the word is for that, because we just shifted our numbers by 1, right? Instead of going with odd numbers, we went with even numbers. We have 2, 4, 6, 8 instead of 1, 3, 5, 7, and so at least there's some sort of connection there to where shifting over some constant a, b, c, and d by 1 shifts our x values by 1. And so this is where I want to sort of make the assertion, or make the conjecture, because I tried this with a couple other numbers, and so let me generalize this. Let me formalize this. I'll just erase the whole thing. Okay, so that's white. Let me get rid of that. Okay. So if we're given x plus some constant a, some integer a, plus b, x plus c, and then x plus d, where a, b, c, and d are all elements of the integers. We'll do positive integers for now because I'm just realizing how poorly thought out this conjecture was I didn't consider non-integers, I didn't consider just like negative numbers in general. So we're going to say that A, B, C, and D are all elements of positive integers because that's all I tested. And there's more, where what was it? If the difference between B and A is equal to 2, the difference between D and C is also equal to 2, then we can say that, what is it? I have this written down. But essentially, we can say after these conclusions are met, then x can equal, there's a smarter way of writing this, but I'll write it like this. Now a minus parentheses a minus 1, which comes out to a minus a plus 1. So we'll just leave it. Then x equals a minus parentheses a minus 1, and x equals c minus, of course, c minus 1 will equal negative 15. This is my little conjecture here. I might come up with a proof for it. I might not. Could be wrong. So, if I'm wrong, there's not gonna be a proof if I'm wrong. If I expand this to something that's not just the positive integers, if it were like just any real number in general, and this held true, that'd be an interesting proof. But this is my conjecture for now. I just wanted to show it because I thought it was relatively interesting. That was a cool little pattern, and it was something I wanted to share. So yeah, stay tuned for a proof. Assuming I'm right, maybe I'll expand this to something that isn't just positive integers, or it's not really positive integers. Something that's not like just like the positive natural, just the natural numbers. Yeah. So if it were, yeah, natural numbers. So we'll say they're not elements of positive integers because I realize how poorly thought out that is. Instead, I think natural numbers is just n. Yeah, let's do. If they're elements of the natural numbers, so if they're 1, 2, 3, 4, whatnot, if they're elements of this, for A, B, C, and D, and these conditions hold true, then sounds like it would equal negative 15. Yeah. Semi-interesting. I just wanted to share this. Thank you for watching.